Great, wonderful. Well, thank you, Jason, and thank you everyone for being here today. It's been really, I'm looking forward to meeting everyone who has a similar or common theme of water. Like Jason mentioned, I'm the new professor in hydrogeology in the department. And early on, people just called me the water guy. To all the students, there's the water guy. And so since I'm the only person hired on as a hydrogeologist. And so what I kind of want to do is just get you a little bit of background about who I am and bleed that into some of my research that I'm working on and some of the research interests that I'm currently pursuing for the near future. I'm a Jayhawker. I know it's a big game tomorrow. I have very low expectations. Probably not even gonna watch it on TV. Recently, I got my PhD from Colorado School of Mines in predominantly hydrogeochemistry. And prior to getting into the academic realm, I was working actually in environmental consulting for years. And so I was professionally trained as a hydrogeologist and worked in a lot of hydrogeochemistry, and enabled me to actually get on the ground type of experience related to groundwater contamination throughout the country. You know, I worked on old refineries, cleaning up oil spills, LNAPL, DNAPL plumes, all the way up to hard rock mining, which kind of led me to a lot of my current research. I was a program director at a two-year college in Leadville, Colorado. If you know where that's at, you know what it's like this time of year. And that's where a lot of my interest in hard rock mining and abandoned mine lands impacts were born. And so I've been tasked with developing this new discipline within the School of Geology and Geophysics. And I'm collaborating with the civil engineering group as well, and trying to get this degree really launched, or this area of emphasis. So I just have a few snippets or pictures to show you some of my research interests. My main overreaching research interest involves natural organic matter and waters. And then also I still maintain a lot of research interest in acid mine drainage, geochemistry, and just talking to Dr. Nairn at OU, there's quite a bit of that in this state as well. So I'm pretty excited. I like acidic water. And fate and transport of metals and surface and groundwater. And then biogeochemistry of wetlands are also something I'm very interested in as well. So just kind of get an idea, what is this stuff, this dissolved organic matter? It's actually throughout nature. It's in precipitation, groundwater, surface water, pore water. And so since it's persistent throughout all aspects of our hydrosphere, it's a great constituent to study. And it's not, it's highly variable, it's very heterogeneous. And so it's very important, it plays a big role in pH and binding of metals and transport, immobilization, redox reactions. And so that really got my interest, and then eventually got my interest in what's its role in aquatic toxicology. So this is just a quick little picture of what it looks like. It's this brown stuff. So basically, if you make tea, you are actually creating dissolved organic matter. So one thing I'm really interested in just happened later on during my PhD work is, wow, there's a seasonal shift in some of these watersheds. So I look at things from a watershed approach. And so I have some watershed sites in central Colorado that are highly variable. They're highly controlled by the climate and also weather patterns as well. So we see that reflection in our organic matter signatures. And so I use various types of spectroscopic approaches using UV-vis spectrophotometers and fluoroscopy. And here's a little excitation emission matrices of some organic matter. So you can see how it fluoresces and leaves this really distinct fingerprint. And so I look at these seasonal patterns, and so if you look at this little shift, it goes from spring, summer, highly aromatic, terrestrial, to not so aromatic, and this is predominantly organic matters derived from water columns. So what we also want to be interested in is, what role does it play in aquatic systems? It's a very busy diagram, I know, but this is the groundwater aspect of it. We have organic matter discharged into streams. We have organic matter in streams. And then one of my big research questions is, how can we distinguish the differences between this? And then what are the seasonal effects in the long term? And then how does it what role does it play in protecting aquatic organisms? And engineers might be interested in its role in DVPs. Future activities I'm interested in, geochemistry of artificial aquifer recharge, and uranium fate and transport. So you can see this picture of uranium ore, and Still working on a lot of aquatic toxicity and some emerging intrinsic groundwater tracers are also some work I'm really interested in spring mooring in the near future. 4 seconds.